following video is on limits. The idea of limits is that we look at some function and we want to examine when x approaches some number, in this case some number a, then our function, it approaches some value of y. So in this first case, our function here is linear, it's just x plus 4. And I want to know what happens when x approaches 3. Well, when x approaches 3, then I end up getting, we could just plug in this case we could plug in the 3 because we're not violating any rules of math. And that's going to give us 3 plus 4, which is going to give us 7. So our limit when x approaches 3 of this function of x plus 4 is 7. Let's look at the next one. Our limit as x approaches -1, let's just plug in the -1 here, and what we get 5 minus 2 times -1, which is going to give us 5 plus 2, which is 7. The limit as x approaches -1 for this function is 7. Let's look at the next one. This case, if we plug in the 4, we don't violate any rules of math, so we're good. So I have the limit. I'm just going to plug in the 4, so I have 3 times 4 minus 1. 3 times 4 is 12 minus 1. That is going to give me 11. The next one, again, no problem, plugging in the 2. So I have 5 times 2 squared minus 3 times 2 plus 2. And order of operations, exponents first, so I have 4. 4 times 5 is 20. And then 20 minus 6 plus 2. 20 minus 6 is going to give us 14, and 14 plus 2 is going to give us 15, 16. All right, so the next one, I'm going to take this limit as h approaches 0 of this function. Let's just take the 0, plug it in, I get 0 squared times 1 minus 0. And 0 squared is going to give me 0. And then 0 times 0 times this 1 minus, we'll do parentheses, 1 minus 0 gives me 1. But 0 times 1 is going to give me 0. Plug in the 0 and I get 0 squared plus 5. 0 squared is 0 plus 5 is going to give us 5. I'm hoping that these get a little bit more difficult. All right, so I have some function. This function is equivalent, my function, if I could think of it as y equals 5, which means that my function is going to be 1, 2, 3, 4, 5. It's going to look like this. So when x approaches, in this case, when x approaches 0, then our y approaches 5. So I get 5. Next one, same thing. This is it looks like a linear horizontal function. So we have 1, 2, 3, 4, 5, 6, 7. So I have this horizontal graph like this. When h approaches 2, 1, 2, y approaches 7. So I get 7. Next one, so when I have a limit as x approaches 0 of some c value, well, whatever the c value is, 1, 2, 3, 4, 5, 6, whatever the c value is, so this would be our y equals c, then that becomes what we converge on, when x is 0, or when x is 1, or when x is 2. In this case, when x approaches 0, we are approaching c, so we get c. Let's look at a more difficult one. In this case, if I plug in 1, then I'm going to get 1 squared minus 3 times 1 over 1, which is going to give me 1 minus 3, that's -2. -2 over 1 is just -2. Take the 2, plug it in. I have 2 squared plus 5 times 2 over 2. That's going to give me 4 plus 10 over 2, which is going to give me, 14 over 2, which is 7. Next one, take the 0, plug it in, and get 0 minus 1 over 0 plus 1. That gives me -1 over 1, which is just going to give me -1. Plug in the 0. Here, this creates a problem. If I plug in the 0, I get 0 over 0, which is undefined. Undefined. So here we have a problem. Well, what we could do at this point is we could say that then x divided by x is just 1. I get 1 here. And so, well, we're basically back to where we were before. So we're going to get that as x approaches 0, then we get 1. So the answer is 1. Now I want to graph this. I want to graph this y equals x over x. because I want to show you what happens really when x approaches 0. Now, I'm saying it's 1 when x approaches 0, which is true, but of course x could never equal 0 because then we have a function that is undefined. So let's see if I can, so I have y equals x over x. We get this line. And what happens when our x value approaches 0? Well, in this case, we see that we have a hole. I don't know if it's worth zooming in on this, but I have a hole in my graph right here because x cannot equal 0. But if x approaches 0, then we get 1. Right? Next one, we have the same problem. If I plug in 0, I get something that's undefined. So let's think of some way of not violating any rules of math. We could rewrite this so I have the limit as x approaches 0 of x. I'm going to factor out an x here. In the numerator, that gives me x times x minus 3 over x. So I have x divided by x, that eliminates out, and I have the limit of x as it approaches 0 of x minus 3. Now I can plug in the 0, and I get 0 minus 3, which is going to give me just negative 3. So as x approaches 0, my y approaches negative 3. So I'm going to graph this one as well. So, oops, wrong one. So in my numerator, I have x squared minus 3x, and in the denominator, I have x. So what happens when x approaches 0? When x approaches 0, we have a hole in our graph again. So we come to the conclusion that when not when x equals, because our function is going to be undefined, but when x approaches 0, then we have negative 3. Our y is negative 3. Our y would approach negative 3, I should say. Right, next one, I'm going to take that 0, and if I plug it in, I get an undefined function, so I'm going to do the same thing, and if I'm going to factor out an x, so I have the limit as x approaches 0 of x times x plus 5 over x. I can divide out, I have x divided by x, which is going to give me 1, so I have the limit of x as it approaches 0 of x plus 5, plug in the 0, and I get 5. So let's graph this one as well. This might be the last one. It depends on, because the concept is basically the same, that I'm going to end up with a hole in my graph. So plus 5 over x. And when x approaches 0, I have another hole in my graph. So when x approaches 0, then my y approaches 5. So do the same thing with this one. I'm going to factor out in the numerator an x. That gives me the limit of x as it approaches 0 of x times 2x minus 1 over x. And these x's divide out. That gives me the limit of x as it approaches 0 of 2x minus 1. And I'm going to plug in the 0. That gives me negative 1. So if I graph this, you're going to see that when x is 0, the function's undefined, there'll be a hole in the graph. So we're going to say when x approaches 0, then our limit is that our y approaches negative 1. So let's continue. The next one, if h is 0, same problem. I'm going to factor out. In this case, I can factor out, so I have the limit as h approaches 0. I'm going to factor out a 2 and an h, so I have 2h, and that's going to leave me in parentheses with h plus 3 over h. H divided by h is just 1, so that's going to give me the limit of h as it approaches 0 of 2, I suppose I could just leave, well, I'll just leave it in parentheses, h plus 3. Plug in the 0, I get 0 plus 3, which is 3. 3 times 2 is 6, so I get 6 here. So 6. All right, so again, if I plug the 0 in, I get an undefined function. I'm going to factor out an h. That gives me the limit as h approaches 0 of h times 3h minus 4 over h. The h's, I'm not going to say cancel out, but they divide out. H divided by h is 1. And that leaves me with the limit as h approaches 0 of 3h minus 4. Plug in the 0, and that gives me negative 4. So when h approaches 0, my y approaches negative 4. Let's look at this f part. Again, if I plug in the 0, I have an undefined function, so I'm going to factor out another h. I have h, and what's left over in parentheses, so I have the limit as h approaches 0 of our function of h times h squared minus 8 over h, and there's h divided by h. Those h's become 1, and we're left with the limit as h approaches 0 of h squared minus 8. I'm going to plug in my 0 to get negative 8. Right, the next one, factor out an x. These are getting sort of boring. It's basically the same thing. And so I'm going to factor out an x to give me x minus 1 over x minus 1. Well, this x minus 1 divided by x minus 1, we should notice that if I plug in this x, if x is 1, if x approaches 1, then I get 1 minus 1, which is 0, and I have 0 in the denominator. So I guess this one's a little bit different. So I misspoke. So now I factored out an x, and so I have x minus 1 over x minus 1, which is just 1. And so I have the limit as x approaches 1 of x equals 1. If I plug in the 1, I get 1. All right, the next one. I'm going to, if I plug in the 2, I get 2 minus 2, which is 0 in the denominator. Again, undefined. So I'm going to rewrite. I'm going to factor out whatever I can in the numerator. So I have a limit as x approaches 2 of x times x minus 2 over x minus 2. Well, x minus 2 divided by x minus 2 is 1, leaving me with the limit as x approaches 2 of x, which is then going to give me 2. And the last one, looks like I need to just factor. Again, if I take this 3, plug it into the denominator, I have 3 minus 3, which is 0. 0 cannot be in the denominator. I'm going to factor the numerator, so I have the limit as x approaches 3 of, what times what gives me negative 6, but when I add them I get negative 1. How about 3 and 2, I'll make this negative, this positive, over x minus 3. Well, the x minus 3 divided by x minus 3, that is 1. I forgot my x. And that leaves me with the limit as x approaches 3 of x plus 2. Take the 3, plug it in, that gives me 5. So the answer here is 5. Hope that was helpful, and have a wonderful day.